All right, so we should define an irrational number. In the context of a standardized test, you should really be thinking that irrational numbers are square roots or pi, right? Square roots that are not perfect squares, obviously. By definition, an irrational number is a number that is not finite, or sorry, like a decimal, I should say. Sorry, a decimal that's not finite, right? Which means it goes on forever, right? So something like 0.5 is not irrational because this is finite, right? So it's 0.5. It doesn't. It stops, right? And doesn't repeat, right? Right, so 0.33333, which is 1/3, right, this repeating, this goes on forever, right, this is not finite, but it repeats itself. So fractions are not irrational. Fractions are not irrational because they'll either be finite or repeat, right? So, okay, so let's look at answer choice A. This would really just be 2 times 4, right, which would be an integer. B, this would be 4 plus 10, which would be an integer. C would be root 10 times root 10, right? The root 10 in and of itself is not an integer, but it would be equal to root 100, right? Which would be 10, and a square root times itself is just the root drops away, right? So it would just be 10. But D would be basically 4 times root 10, or root 160. This is still going to remain a square root. It's not a perfect square, so it would be answer choice D.